So here's a quick video about how to graph a Limacon, which is not so hard to spell, but is harder to pronounce. The example that I'll use is r equals 3 minus 6 sine of theta, and the strategy will be the same as with the cardioid. We'll consider the sinusoid y equals 3 minus 6 sine of x. So we'll graph that sinusoid on the left here. I'll use a scale of 3 so that I can easily show the midline at 3. Dotted line cutting right across there. And since the amplitude is 6, the sinusoid will rise up 6 and down 6, up to 9, and down to -3. It's a negative sine, so it starts at its midline and it drops down first to its minimum, then back up to its midline, through its maximum, and finishes at its midline. Connecting the dots here with a red curve, you can see a nice graph of y equals 3 minus 6 sine of x. And there are a few points on that graph that we'll use to graph our Limacon. First, these 5 points marked in green, but also these 2 extra ones marked in blue. The ones in blue are of particular note because these are points where the radius is 0, and thus the curve goes through the pole. It does not matter what the angle is so much. The point will definitely be at the origin because the radius is 0. So I'll label the other points in green, A, B, C, D, and E, and I'll plot them over here on the right. A is a radius of 3 with an angle of 0. And then the next point after A, I'll just mark in blue. That's going to be the pole. B is an angle of 90 degrees, but a negative radius, -3, so it's down there in the south. Letter C is back to being a positive radius of C, but an angle of 180 degrees, so it's over there to the left. And then D is going to be way down here at 270 degrees at a radius of 9. E is back where we began. So in connecting the dots, I must go A to the pole to B, back to the pole to C, and then come down to D and finish up back where I started. And that's the general idea on how to graph a Limacon. Just make sure you visit the pole and you create that neat little loop there in the middle. One sad thing about Limacons is not all of them have loops. So here's a quick example of how to graph a Limacon without a loop, without getting into necessarily why some Limacons have a loop and why others don't. That's something that's pretty quick to figure out on your own. So the example I'll use is r equals 2 plus cosine theta. So let me get a graph up here. There we go. Okay, so we'll sketch a graph of r equals 2 plus cosine theta. First, we'll graph it as if it were a sinusoid, 2 plus cosine of x. I should say 2 plus cosine of x. By drawing the midline there at 2, and the amplitude's just 1, so it rises up to 3. It's a cosine, so it starts at its highest point. These are the 5 critical points that I'd like to graph. Connect them with a line so that you see the graph of y equals 2 plus cosine of x. And notice that there are no zeros. It never crosses the x-axis. That means the radius never turns negative, and thus our Limacon will not have a loop. So the points are A, B, C, D, and E. And as I plot them over here on the right, A is at 3 with an angle of 0. B is at 2 with an angle of 90. C is at 1 with an angle of 180. And D is at 2 with an angle of 270. E is back where we began. Simple connecting the dots. You get a little sideways egg-looking thing. No loops. Simple little Limacon, and that's it. That's how you graph a Limacon with and without a loop.